Good morning, students. Today you'll discuss the last topic of class 10th physics syllabus. So that is scattering of light. So the scattering of light, when sunlight enters the atmosphere of the earth, then this sunlight is absorbed by the small atoms and molecules of the gases present in the earth atmosphere. So these atoms and molecules re-emit light in all directions. So the process of re-emitting or re-radiating the light by atoms and molecules in all directions is known as the scattering of light. See here in diagram, in this the sunlight is incident on the atoms. These atoms, the sunlight is absorbed by the atoms or molecules, and it is the atoms and molecules again re-emits the light. So this is known as a scattered light. And remember, the atoms, molecules, or the other particles is known as a scatterer. So the intensity of a scattered light, remember, depends upon the two factors: the wavelength of light, the size of the particles causing the scattering. So depending upon the size of the scatterer, the following two situations arises. First, if the scattering particle, that is air molecules, atoms, are of size smaller than the wavelength of the light, then in this case the intensity of a scattered light, remember, the intensity of a scattered light is inversely proportional to the fourth power of the wavelength of incident light. It means more is the wavelength, less is the intensity of scattered light. That is why this formula is very important, because the scattering intensity of scattered light is more if the wavelength is less, and that is less if the wavelength is more. So now this is about, and the second situation, if the scattering particle are of size greater than the wavelength of light, then this relation is not valid. It is possible when the earth atmosphere is polluted or contains dust and smoke particles. So in this case, the size or dust or small particles, in this case the size of dust and smoke particles or water vapors in the atmosphere is large as compared to the wavelength of incident light. So in this case, all colors are scattered equally. Therefore, the sky appears grayish when earth atmosphere is polluted, or clouds are generally appears white. So there are some important phenomena which occurs due to a scattering of light. So these phenomena, such first is blue color of a sky. So the blue color of a sky, when light from the sun enters the earth atmosphere, the scattering of different colors takes place due to interaction with large number of very small particles in the earth atmosphere. So the wavelength of blue color is much smaller than the red color. Therefore, the intensity of blue light is scattered much more than that of the red color. Now, this point must be noted, that the sky appears black in the absence of the earth atmosphere, because no color is scattered in that situation. Now the another is reddish sun and sunset or sunrise. Reddish sun and sunset on sunrise. At sunset or sunrise, the sun and its surrounding appears red because of the scattering of light. The same concept you can apply here. The light from the sun or sunset or sunrise travel a larger distance through the earth atmosphere to reach our eyes. So this light is deprived of the blue color due to large scattering of blue light by the particles present in the atmosphere, and rich in red color. So the sun appears reddish at sunset or sunrise because the red color is least scattered and remaining colors are generally scattered. We can also understand it that when the sun is over the head, there is less scattering of blue colors because of the less distance as compared to the distance of the sun. Similarly, the danger signals are red in color. The concept is same. All colors are scattered much more than that of the red color. So the red color suffering minimum scattering remains confined around the signal, which in turn illuminates the signal significantly. The another is the clouds are generally white. The concept is that the clouds consist of dust particles and water droplets, and the size of the scatterer is much more than the wavelength of the incident light. So all colors of white light are scattered equally. Hence, the light which we receive through the cloud has all the colors of light. As a result of this, we receive almost white light. Therefore, the colors are generally white. So there are so many applications of scattering of light. So this is the last topic of the class 10 physics syllabus because other topics have been deleted. So thank you very much, and you will discuss in detail in live classes.